Alright, two of the most important terms in statistics are population and sample. A population is a set of all objects or individuals of interest, or the measurements obtained from all objects or individuals of interest. A sample is a subset of this population. Perhaps we want to analyze the average time it takes for a BSU student to graduate. The population in this example would be all Boise State students, and a sample might only be 200 or 300 students. If we use the entire English alphabet as the population, our sample may be only half or a quarter of these. Later on in the semester, we'll learn how to determine the appropriate sample size. Descriptive numerical measures such as the average or proportion that are computed from an entire population are called parameters. Corresponding measures for a sample are called statistics. Once a manager decides to gather information by sampling, he or she can use a sampling technique that falls into one or two categories: statistical or non-statistical. Both non-statistical and statistical sampling techniques are commonly used by decision makers. Regardless of which technique is used, the decision maker has the same objective: to obtain a sample that is representative of the population. Statistical sampling assigns a probability of an item being selected. Non-statistical sampling is non-chance related, and one of the most common methods used to sample is convenience sampling. Statistical sampling methods, also called probability sampling, allow every item in the population to have a known or calculable chance of being included in the sample. The fundamental statistical sample is called the simple random sample. Other types of statistical sampling discussed in this text include stratified random sampling, systematic sampling, and cluster sampling. Simple random sampling is the method most people think of when they think of random. Simple random sampling is the method most people think of when they think of random sampling. It can be obtained in a variety of ways. You can either use the random numbers table in your Appendix A of your text, or as I will show you in this video, you can use Excel. Alright, so go ahead and open Excel. Suppose we had 300 students in a class and we wanted to randomly select 300. Suppose we had 300 students in class and we wanted to take a random sample of 10. And which students would those be? Well, we can figure it out using the random number generation. We'll go into Data, Data Analysis. Make sure you have the Data Analysis toolpack loaded. Click on Data Analysis and go down to Random Number Generation. Click OK. Number of random variables we'll set to 1, and we want 10 students selected, so we'll put 10. We want the distribution to be uniform, and since we have 300 students, we will add 300 in the range, and make sure we select the output range as A1. Click OK. And those are our students. Obviously we can't have a partial student, so we want to eliminate the decimal points. So go up here to the numbers and bring those decimal points back. So this tells us that we have student 55, 187, 67, 59, so on and so forth. One thing to note is we can't have duplicates, and we do have duplicates here. We have a 55 here and a 55 here. So you'd probably want to expand that range. Instead of including 10, we'd maybe want to include 20 or 15. Alright, so that was simple random sampling. Stratified random sampling is an alternative method that has the potential to provide the desired information with a smaller sample size. This is a method that Gallup polls use and other polls. Start by dividing the population into subgroups. These are called strata. Stratified random sampling is an alternative method that has the potential to provide the desired information with a smaller sample size. Stratified random sampling is an alternative method that has the potential to provide the desired information using a smaller sample size. Start by dividing population into subgroups, called strata, according to some common characteristic. Perhaps this is gender, income, or education level. Select a simple random sample from each subgroup and combine samples into subgroups into one overall sample. The key behind stratified sampling is to develop a stratum for each characteristic of interest that has items that are homogeneous. Multiple layers of stratification can further reduce the overall sample size. The following example illustrates how stratified sampling is performed. Each year, the Federal Reserve Board asks its staff to estimate the total cash holdings of U.S. financial institutions as of July 1st. The staff must base the estimate on a sample. Note that not all financial institutions are the same size. A majority are small, some are medium-sized, and some are large. However, the few large institutions have a substantial percentage of total cash on hand. As an alternative to the simple random sample, the Federal Reserve staff could divide the institutions into 3 groups called strata: small, medium, and large. Staff members could then select a simple random sample of institutions from each stratum and estimate the total cash on hand for all institutions from this combined sample. Systematic random sampling is a statistical sampling technique that involves every kth item in the population after a randomly selected starting point between 1 and k. The value of k is determined as a ratio of the population size over the desired sample. Cluster sampling is a method by which the population is then divided into groups, or clusters, that are each intended to be mini populations. A simple random sample of m clusters is selected. The items chosen from a cluster can be selected using any probability sampling technique.